Thank you all. You've made it until now, so kudos to you all. So this is the final session, and hopefully we'll try to wrap up quickly. So this presentation is a reflection of my thoughts on a topic that has been very close to my heart for many years now. It's about using real-time for social security, right? And so that's the topic for this particular session. And the question that we are trying to answer in this particular session is why do government aid and payments still take days or even weeks when everything else happens instantly, right? So that's what we are here to explore, how Apache Kafka and Flink can revolutionize this process, making it real-time, efficient, and reliable, right? So let's get started. So this is the agenda. So this presentation will be covered in 3 parts. The part 1 is what is the urgency, right? And is the need for faster benefits disbursement, is that just a convenience or is it a necessity? And then we'll look at the core problems with the traditional batch-based payments processing, disbursements, and what is the impact of those delays, real-world impact, right? And then in part 2 of this presentation, we'll look at what is real-time stream processing and how Kafka and Flink eliminate those bottlenecks. We'll do a little sort of, dive into the architecture of Kafka and Flink and look at how some of those problems that the batch processing creates get addressed using this architecture. And then part 3, we'll do a shoulder-to-shoulder comparison of a benefits disbursements workflow when done using traditional batch processing versus real-time streaming, right? And then we'll have some final quotes and then we'll wrap it up for the day. So, right, so the real-time social security, why is this a critical need, right? And so if you look at situations like natural disasters, families lose everything overnight and they need financial support, but they have to wait for days and weeks because of slow, outdated processes. And what does this mean? Missed medical care, unpaid bills, food insecurity, and governments still rely on batch processing where payments are queued, scheduled, and delayed. Now, I'm probably going to talk about 2 scenarios. For those of you who have parents who have retired from government or from central government or state government services, may be able to relate. So for all the retirees, there is a need to submit a life certificate in November, right? Pretty much every year in November, for their pensions to continue and social security to continue, right? Now, what if, that life certificate process submission gets delayed? And this is what happened, with one of our neighbors where we stay. They're aged, couple. The children stay far away and the family situation does not allow the children to come over easily. So the male individual, he passed away sometime in October, just before the life certificate was to be submitted. And then the other individual had to struggle to get the process underway, and she had to incur real difficulties in terms of getting the pension reinstated, right? And that's because the life certificate deadline got missed out, the November deadline got missed out, right? And do you know, if you miss the November deadline, when is the next deadline that you have to submit the life certificate? Does anyone know here? It's February. So meaning, until February, you'll not have your pension, November, December, January, and you'll not have your other social security benefits. Imagine, the impact of this on the vulnerable population, right? Now, the second scenario where I've seen this happening is a couple of years back as a part of the Ayushman Bharat scheme, right? And I was in Hyderabad getting a treatment for my mom done, but then I noticed, a less fortunate family coming to the hospital on a medical emergency. But then since the fingerprints biometrics did not match, we face this problem. The biometrics change over time and then the match does not happen. They were denied the treatment in that medical emergency, right? So what does it need? You'll have to go through a re-enrollment process, get your fingerprints and biometrics updated, and only then you'll probably be eligible for the Ayushman Bharat scheme. Right, so we saw this also happening during the COVID-19 pandemic, not just in the subcontinent, but across the world as well, where people who are in real need of social security, they have to wait for days and weeks due to these batch processing systems that are in place and endure enormous amount of difficulty, right? So this is the need. This is the need, and that's the reason why social security, real-time social security, is needed, right? Now, so we have seen this. What are the problems with the traditional batch processing? So payments are scheduled in batches, meaning if you miss the window, you have to wait. If you miss the mid-November window, you have to wait until February end to submit the life certificate and reinstate your pensions. Failures in emergencies, right? The disbursement systems can't adopt in real time, leading to bottlenecks. Your fingerprint does not match, there's an issue, you have to wait, there's a failure, and you're again inflicted with enormous difficulties. Also, from a study that was done, these batch processing based disbursements are inefficient. A lot of manual interventions are needed, which slow down the things even further and increase the operational costs, right? So these are the problems associated with the traditional batch processing. Then, so this is a typical batch processing architecture diagram. I've been in the data analytics space for 20 plus years now, and making data available to the consumers and the customers in the right fashion and enabling them has been my job. So this is a typical batch processing architecture, and if you see here on the far left, you have the data ingestion that happens through typical overnight jobs, and then you have the processing into the different layers, landing, staging, core, semantic, right? And with the ELT processing happening on top of that data, and before it gets consumed by the downstream applications. In this case, we're talking about the benefits disbursement system, right, or the payment system, okay? So we see here the processing takes hours due to the sequential ETL pipelines. The payments get queued, and if anything fails, the entire process resets. So what is the impact? The citizens have to wait 12 to 48 hours for funds they need right now, right? And this architecture and this processing does not help with that process, with that need. So batch processing is traditionally good for historical reporting, but it's not meant for real-time decision making, right? And this leads to delays that directly impact those relying on those payments. Now we'll sort of double click. There's a little involved slide where this talks about the ecosystem components of a traditional batch processing. And the purpose of this particular slide is to identify those bottlenecks in each of those layers. So where do the first set of bottlenecks happen, right? In the data ingestion. Now, if you're talking about, let's say, government data or citizen data, right, or emergency aid data, that's not updated in real time. So it flows in batch. And then you have the outdated records that lead to delays in verification and eligibility approval. Bottleneck 2 happens in this layered zone, right, where the batch ETL jobs run on a schedule and not on demand. Processing large volumes adds multiple hours of waiting time. And then bottleneck 3 is manual review and compute constraints. Payments can't be automated by the downstream systems, and one failure, the entire batch has to be reprocessed, which means adding another day of delay, right? And then you have the payments systems, which is the bottleneck 4, where the payments are approved, but then they get queued up and they are not instantly disbursed, right? All of this means citizens suffer unnecessary hardship while waiting for funds. So this is a case study. Let's say we try to put a human face to this problem. We have someone called John Doe, who is an hardworking individual just like many of us. One day he is unexpectedly hit with a crisis. It could either be a medical emergency or a natural disaster or a sudden job loss. So John applies for the government aid, in this case the recent hurricanes that have happened in Florida in US. His request gets accepted, but the batch processing runs only once per night. So his eligibility checks fails due to outdated records. This adds another 24 hours of delay. And then once approved, the payments are processed weekly, adding further delay. So John's critical funds are stuck in bureaucracy while he struggles to survive. So back to the question, is real-time processing of Social Security just a convenience? No. It's a matter of survival, right? So this is not just about inefficiency, it's system failure that hurts real people, right? And this particular slide is a study done by World Bank in 2022, wherein the devastating consequences of delayed benefits were conducted as a study. And so the first one was the Hurricane Katrina in 2005, where families waited for weeks for relief funds because batch systems couldn't handle the demand. And then we have the COVID-19 pandemic. Unemployment and delays left millions in financial limbo. And then we have the recent wildfires, which is ongoing in California, where emergency relief is delayed when people need the most, right? And what are the consequences? Like I said, missed rent payments, evictions and mounting debt, delayed unemployment benefits, right? And then it keeps getting compounded, right? And we can't afford these delays anymore. Okay, so this is the first part of the presentation. Next, we'll see how real-time stream processing eliminates these bottlenecks, ensuring that when people need help, they get it instantly. So, introducing the real-time stream processing architecture. And again, the fundamental question is, tomorrow, let's say you have elders in your family who ask, Why are my payments getting delayed? Now you know that the batch processing, and you know where those inordinate delays happen in each of those steps, right? You can at least tell them that this is what is happening, make them aware. So we have seen traditional batch processing slows everything down, and in real-time stream processing, in batch processing, everything happens in chunks at scheduled intervals, which means payments wait in line until the next batch runs. ETL processes queue up, adding delays at every stage, and if something fails, we start over again. The solution: stop waiting, move to the event-driven system, and we're talking about real-time stream processing, wherein we don't have to wait for hours or days, and the system processes the data the moment it arrives. So there's no waiting for batch cycles, instant validation and transformation, and even the failures are handled in quicker time, right? So how does real-time stream processing solves this problem? With event-driven architecture, new data, if we're talking about citizen data or government data and calamity data, is processed instantly. Then we have the stream processing engines like Kafka plus Flink. Data is transformed and validated as it flows, reducing delays. And then we have the event-based decision making, where the system triggers the actions like funds transfers, right, instantly. So what is real-time stream processing? So this conference is about streaming. I'm not going to sort of teach that here, but so the real-time stream processing is continuous ingestion of data in the form of events, and processing of the data as it generates, right? And it enables immediate decision making, improving the operational efficiency and real-time insights, right? So we see here these are the data sources that generate the data in terms of events. So we have the message broker, Kafka, which is pretty popular. And then we have the streaming engines. We have seen Flink here, but then there are these other alternatives as well. And then we have the downstream consumption systems, right? So this is the real-time streaming architecture. And unlike batch processing, it's event-driven, and actions happen as soon as the data flows in. So the key components of this architecture are data ingestion, where continuous flow from IoT devices, government records, citizen applications, and financial transactions keeps happening. Then you have Apache Kafka, which acts as the central nervous system, which efficiently streams data to where it is needed. Or 80% of Fortune 100 companies use Kafka for its scale, fault tolerance, and data consistency. So we have seen presentations before that where Kafka has been used for billions of events per day. Then we have Flink, which is a real-time processing engine that operates on the streaming data. Unlike traditional databases that process data at rest, Flink processes data in motion, applying transformations, aggregations, and validations dynamically, right? And Flink has got functions like filtering, aggregation, transformation, windowing, right? So a combination of Kafka and Flink is what constitutes real-time stream processing. And what does this result in? We're talking about ultra-low latency, where processing happens in milliseconds to seconds, which is perfect for social security, fraud detection, and financial transactions. And then there is event-based automation, instant alerts, decisions, and fraud detection happens instead of post-factum. Then there is scalability and reliability that handles massive real-time workloads without breaking down. What does this result? Better citizen experience, no delays, no uncertainty, just financial aid when it is needed. So a little more into we've looked at the real-time stream processing architecture, but there are two fundamental paradigm shifts that this architecture supports. What are those two paradigm shifts? One is data in motion versus data at rest. The traditional batch systems process data at rest. We have seen starting from sort of gathering, storing, analyzing it later. Real-time stream processing works on data in motion, reacting instantly as new information arrives. This enables immediate fraud detection, real-time benefit approvals, and instant funds disbursements. So one of the analogy in one of the articles that I was reading is, you think of batch processing like taking photos of traffic every 30 minutes, and you might miss an accident. But whereas with real-time stream processing, it's like having a live video feed and you always know what's happening, right? And that's what this data in motion supports. And then the second paradigm is shift left architecture. And this approach decouples the data storage from processing and consumption and improves speed and accuracy. And what does this result? It results in faster insights, processing data as it is arrived as it happens in a pipeline, ensuring higher data quality and also lowering the costs, right? So these two paradigm shifts is what drive use cases like real-time social security and real-time fraud detection, right? And those are the key. Now, we've looked at two parts: the problem statement, the need for real-time social security benefits, and what are the problems associated with the traditional batch processing. We have looked at the solution, which is real-time streaming, and looked at the technology that supports that, Apache Kafka and Flink. Now we're getting into the part 3, the last segment of this presentation. So this is a benefits disbursements workflow when done using the batch processing, right? It's a little sort of busy slide. If you see here, it talks about 23 steps in all, split across the different layers of this batch processing architecture from left to right. And what has been highlighted in red is the steps that add delay in the typical batch processing, right? So beneficiary records are received and queued up for processing. So you have to wait for the next batch cycle, right? They are queued up. That causes a delay. Data staging delays occur due to large file sizes, right? So that's another step that causes delay. Then you have manual reviews required for inconsistencies and missing information, right? So likewise, so these are those different steps highlighted in red in this workflow that cause the batch processing to be slow and inordinately painful. So if we were to do this process using real-time streaming, how would it look like? Right, so this is a benefits disbursement workflow if it were to be done using real-time stream processing. And we see here that there's no queuing, event-based submission, no file queuing. Agencies publish beneficiary records in real time via Kafka. Instant data ingestion and Kafka distributes the data immediately, skipping staging delays. Real-time eligibility checks. Flink validates records on the fly instead of waiting for batch. You have the continuous fraud detection that runs in stream, stopping bad transactions before they even happen. And then you have the immediate benefit computation that Flink calculates entitlements dynamically, and there's no waiting. Then we have the automated approved transactions, no manual approval bottlenecks. Pre-approved transactions are sent straight to the payment, right? And then you have the instant bank transfers via APIs. Again, no batch delays here. And then there is real-time reconciliation and automated retries, right? So what is the impact? Whatever were those red steps that we saw in the batch processing in the earlier slide have got addressed in this particular flow using Apache Kafka and Flink. And the impact, citizens get their money instantly, governments cut operational costs, and the system works seamlessly without human bottlenecks. So this is the future of the social security disbursement, which is fast, transparent, and reliable, right? So this is a comparison. What we see here is a shoulder-to-shoulder comparison of the tangible differences if you were to do the social security benefits disbursements using the batch way and using the real-time streaming way, right? So if you see here, we're talking about a slow, inefficient process which takes about 48 to 72 hours, and each of these steps, right? Data extraction to disk-based processing, and then batch orchestration, right? And then manual intervention and payments processed in bulk, leading to a total elapsed time of about 72 hours, right? And if this were to be done with real-time streaming, we are saying that this whole disbursements probably might happen in about minutes time as against hours and days, right? So that's the comparison that the real-time streaming brings to social security, right? So no batch delays, no manual interventions, and no waiting, just instant processing and payments. So again, like I said, this was a topic that was pretty close to my heart, and these are some inspirational quotes that I've put together. So technology that uplifts the mankind is the real technology, and we know that justice delayed is justice denied. So as social security delayed is social security denied, and real-time aid is not a luxury, it's a necessity. So the key takeaways from what we have seen so far is clearly real-time stream processing is the method that should be adopted for benefits disbursement, because batch processing is outdated, inefficient, and it's slow. Real-time processing ensures faster and fairer distribution of benefits. And we have Apache Kafka and Flink that provide scalable, event-driven solution for processing. So with this, I'll come to the end of my presentation. And here are the references that I've used to build this presentation. And I would like to thank Varsha Sharma and Bharat Chari and Deeptiman Chowdhury, who are Confluent employees who have helped me review this content, and one other individual called Surendra Reddy, right? So with that, my presentation is done, and like I said, I probably gave you about 20 minutes back. Thank you.
Thank you, Kalyan.
Definitely a good presentation. So looking at the comparison, right, one would rightly say, yes, real-time is far more better than the batch cycles. But how would we manage the high cost factor which comes with the real-time processing?
Yeah, that's a very pertinent question. And I should have included that slide in my study. So there's a total cost of ownership comparison which was done, comparing the traditional batch way of doing the social security benefits disbursements and versus the real time. So although this myth that real time adds complexity and cost is there, but the initial costs around the infrastructure, or let's say the services, may be higher. But if you look at a 3-year horizon, and if you look at the different cost headings across, like I said, the infrastructure, the license fees, then the FTE costs, the recurring costs, the non-recurring costs, that study clearly said that the real-time architecture is financially much better than the traditional batch processing as well. That's a good question. I don't have that reference with me right now, but over a period of time, the real-time stream processing definitely comes to be a cheaper and a much economical solution. So let me ask a question. Okay, so has anyone used Jeevan Praman application? Right. So I talked about the life certificate submission example. Right now, so is Jeevan Praman a real-time stream processing? Okay, so it is not. So why is it not real-time stream processing? Right. So see, although the process of capturing the biometrics has been automated, so where you use the Jeevan Praman application to do the iris scan, and then it triggers an Aadhaar-based authentication with an SMS, and then you can download the confirmation. But then, you'll have to wait for 4 or 5 days before you get that SMS. Only after you get the SMS saying that your life certificate has been approved, you will be eligible for the pension payments. Otherwise, you'll have to go through the struggle. Okay, so that's all. Thank you, everyone.